Space is usually messy, uneven and unpredictable. Galaxies stretch, collide and twist into countless imperfect shapes. Light travels in straight lines and gravity simply pulls things inward. At least that's how it seems, until something appears that quietly breaks all of those expectations. Far from Earth, a distant galaxy appears as a near-perfect ring of light floating in the darkness. It isn't a real ring. Nothing was built or shaped that way. Instead, gravity itself bent space so precisely that light curved into a circle. This rare phenomenon is known as the Cosmic Horseshoe, and it exists only because the universe briefly aligned in a way that almost never happens. In this slow, calming journey, we'll gently explore how gravity can bend space, how light can be curved without touching anything, and why this almost impossible symmetry makes scientists pause. There's no rush to understand every detail. Each idea unfolds naturally, allowing your thoughts to drift while the universe explains itself at its own quiet pace. If you enjoy peaceful explorations of strange and beautiful cosmic phenomena, you can subscribe to Theories Before Sleep for more slow, thoughtful journeys through space, time and reality. As we continue, let the noise of the day fade away. The universe doesn't hurry, and neither do we. Tonight, we'll follow light as it bends, curves, and briefly reveals just how flexible reality can be. When we first learn about gravity, it's usually described in simple terms. Objects with mass pull on other objects with mass. Planets orbit stars, moons orbit planets, and galaxies hold themselves together through this invisible attraction. It feels intuitive, almost ordinary. Gravity pulls things inward. Light moves straight. Space is just the stage where everything happens. But the cosmic horseshoe exists because none of that is quite true. At the deepest level, gravity does not simply pull objects toward one another. Gravity changes the shape of space itself. Mass tells space how to curve, and curved space tells everything inside it. Matter, energy, even light, how to move. This idea, first described by Einstein, sounds abstract until the universe provides a visual demonstration so clear that it feels almost impossible. The cosmic horseshoe is one of those demonstrations. Far away, billions of light years from Earth, two galaxies happen to align in a very specific way. One galaxy lies closer to us, massive enough to significantly curve space around it. Behind it, much farther away, sits another galaxy emitting light in all directions. Normally, we would see only the foreground galaxy, and the distant one would remain hidden or appear as a faint smudge. But in this rare alignment, the foreground galaxy bends the space around it so strongly that light from the distant galaxy is forced to curve as it travels toward us. Instead of moving in straight lines, the light follows the curved geometry of space itself. By the time it reaches Earth, that light no longer appears to come from a single distant source. It wraps around the foreground galaxy, forming a luminous arc that nearly closes into a perfect circle. This is the cosmic horseshoe. It is not a structure. It is not a ring of matter. It is an illusion created by gravity, space, and light cooperating with extraordinary precision. The distant galaxy is still where it always was. The foreground galaxy is still ordinary in shape. What changes is the path the light takes through the universe. What makes the cosmic horseshoe so unsettling is how close it comes to perfection. Gravitational lensing is not rare in itself. Astronomers have observed many distorted arcs, partial rings, and smeared images of distant galaxies. Most of them look irregular, broken, incomplete. The universe rarely aligns anything so neatly. Yet here, the alignment is almost exact. For the cosmic horseshoe to form, several conditions must be satisfied at once. The foreground galaxy must be massive enough to significantly warp space. The background galaxy must be positioned almost directly behind it from our point of view. The distances must fall within a narrow range. The angles must be precise. Even small deviations would break the ring into a partial arc or scatter the light into a messier shape. And yet, all of this happened. This raises an uncomfortable question. If such precise alignments are possible, what else might the universe be capable of that we haven't yet seen? The Cosmic Horseshoe forces scientists to confront how often intuition fails at cosmic scales. We tend to imagine the universe as chaotic, random, and uncoordinated. On small scales, that's often true, but gravity operates patiently, shaping large-scale structure over immense spans of time. Given enough time and enough space, even extremely unlikely configurations can emerge. The Cosmic Horseshoe is not evidence of design or intention, it is evidence of inevitability. In a universe with trillions of galaxies, some will line up in ways that feel almost too perfect to be real, yet the discomfort remains because perfection feels wrong. When humans see symmetry, we instinctively associate it with purpose. But the universe does not share our instincts. Symmetry in this case emerges not because the universe prefers it, but because the rules allow it. Gravity bends space smoothly. Light follows those curves faithfully. When conditions align, the result is elegance without intention. The Cosmic Horseshoe also provides something extremely valuable to science: a natural lens. Because the foreground galaxy magnifies and distorts the background one, astronomers can study details that would otherwise be far too faint or distant to observe. Features that would be invisible become detectable. Star-forming regions, internal structure, and distribution of matter within the distant galaxy are revealed through the curved light. In this way, the Cosmic Horseshoe is not just a curiosity, it is a tool. By analysing the shape and brightness of the ring, scientists can map the distribution of mass in the foreground galaxy, including dark matter. Dark matter does not emit light, but it contributes most of the gravitational influence. The way the light bends reveals where mass must be present, even if nothing can be seen directly. This makes the Cosmic Horseshoe one of the clearest demonstrations that dark matter is real, structured, and dominant. The ring's smoothness suggests that the mass creating the lens is distributed evenly, without large clumps or disruptions. That smoothness is itself surprising. Many galaxies have messy internal structures, yet here, gravity behaves as if guided by a nearly symmetrical mass distribution. Again, the universe appears calmer and more orderly than expected. There is also a temporal aspect to the Cosmic Horseshoe that is easy to overlook. The light forming the ring left the distant galaxy billions of years ago. It began its journey when the universe was much younger. The foreground galaxy bent that light long after it was emitted, and we receive it now in a universe that has expanded dramatically since then. What we see is not a single moment, but a layered history. The Cosmic Horseshoe is a fossilized interaction between galaxies separated by vast distances in both space and time. The alignment that created it may no longer exist in the same way. Galaxies move, space expands. The configuration that produced this near-perfect ring may already be dissolving, yet the light preserves it. This adds a quiet, emotional weight to the image. The ring looks stable and complete, but it represents a fleeting moment stretched across billions of years. It is a reminder that even the most striking cosmic structures can be temporary, their appearance sustained only by the long travel time of light. Another reason the Cosmic Horseshoe unsettles scientists is how it challenges visual intuition. We are used to associating circular shapes with physical boundaries. Planets are round, rings imply rotation, structures suggest formation mechanisms. But the horseshoe has none of these. There is no spinning ring, no orbiting matter, no structure holding it together. It is space itself doing the shaping. This realization pushes us to reconsider how much of what we see in the universe is real in the way we assume. Many cosmic images are not straightforward photographs. They are projections shaped by gravity, motion, and perspective. The universe we observe is filtered through curved space-time. The Cosmic Horseshoe makes that filtering impossible to ignore. It also quietly reinforces one of the strangest ideas in modern physics. That space is not passive. It is active, it responds to mass. It bends, stretches, and redirects reality itself. In everyday life, space feels empty and inert. In the presence of extreme mass, space becomes dynamic. The horseshoe is space announcing that it has geometry. There is something deeply calming about this idea when approached slowly. The universe is not chaotic in the way noise is chaotic. It follows rules consistently, even when the results surprise us. The cosmic horseshoe exists not because something went wrong, but because everything behaved exactly as it should. Gravity curved space. Light followed, we happened to be in the right place to see it. Nothing more was required. As we sit with this image, it's worth allowing the mind to soften its need for explanation. You don't need to calculate angles or memorize equations. It's enough to recognize that reality is flexible, that space can curve, and that light is willing to follow wherever that curvature leads. The cosmic horseshoe is not shouting a message, it is whispering one. It tells us that the universe is capable of beauty without intention, precision without planning, and symmetry without design. It tells us that what feels impossible is often simply unfamiliar. And most of all, it reminds us that reality does not need to make sense in human terms to be real. It only needs to follow its own rules. As we continue, we'll move deeper into what this rare alignment reveals, not just about gravity and galaxies, but about how the universe quietly demonstrates its most profound truths when we take the time to look slowly. When we first learn about gravity, it's usually described in simple terms. Objects with mass pull on other objects with mass, planets orbit stars, moons orbit planets, and galaxies hold themselves together through this invisible attraction. It feels intuitive, almost ordinary. Light moves straight. Space is just the stage where everything happens. But the cosmic horseshoe exists because none of that is quite true. At the deepest level, gravity does not simply pull objects toward one another. Gravity changes the shape of space itself. Mass tells space how to curve, and curved space tells everything inside it, matter, energy, even light, how to move. This idea, first described by Einstein, sounds abstract until the universe provides a visual demonstration so clear that it feels almost impossible. The cosmic horseshoe is one of those demonstrations. Far away, billions of light years from Earth, two galaxies happen to align in a very specific way. One galaxy lies closer to us, massive enough to significantly curve space around it. Behind it, much farther away, sits another galaxy emitting light in all directions. Normally we would see only the foreground galaxy, and the distant one would remain hidden or appear as a faint smudge. But in this rare alignment, the foreground galaxy bends the space around it so strongly that light from the distant galaxy is forced to curve as it travels toward us. Instead of moving in straight lines, the light follows the curved geometry of space itself. By the time it reaches Earth, that light no longer appears to come from a single distant source. It wraps around the foreground galaxy, forming a luminous arc that nearly closes into a perfect circle. This is the cosmic horseshoe. It is not a structure, it is not a ring of matter, it is an illusion created by gravity, space, and light cooperating with extraordinary precision. The distant galaxy is still where it always was. The foreground galaxy is still ordinary in shape. What changes is the path the light takes through the universe. What makes the cosmic horseshoe so unsettling is how close it comes to perfection. Gravitational lensing is not rare in itself. Astronomers have observed many distorted arcs, partial rings, and smeared images of distant galaxies. Most of them look irregular, broken, incomplete. The universe rarely aligns anything so neatly. Yet here, the alignment is almost exact. For the cosmic horseshoe to form, several conditions must be satisfied at once. The foreground galaxy must be massive enough to significantly warp space. The background galaxy must be positioned almost directly behind it from our point of view. The distances must fall within a narrow range. The angles must be precise. Even small deviations would break the ring into a partial arc or scatter the light into a messier shape. And yet, all of this happened. This raises an uncomfortable question. If such precise alignments are possible, what else might the universe be capable of that we haven't yet seen? The Cosmic Horseshoe forces scientists to confront how often intuition fails at cosmic scales. We tend to imagine the universe as chaotic, random, and uncoordinated. On small scales, that's often true. But gravity operates patiently, shaping large-scale structure over immense spans of time. Given enough time and enough space, even extremely unlikely configurations can emerge. The Cosmic Horseshoe is not evidence of design or intention, it is evidence of inevitability. In a universe with trillions of galaxies, some will line up in ways that feel almost too perfect to be real, yet the discomfort remains, because perfection feels wrong. When humans see symmetry, we instinctively associate it with purpose, but the universe does not share our instincts. Symmetry in this case emerges not because the universe prefers it, but because the rules allow it. Gravity bends space smoothly. Light follows those curves faithfully. When conditions align, the result is elegance without intention. The Cosmic Horseshoe also provides something extremely valuable to science: a natural lens. Because the foreground galaxy magnifies and distorts the background one, astronomers can study details that would otherwise be far too faint or distant to observe. Features that would be invisible become detectable. Star-forming regions, internal structure, and distribution of matter within the distant galaxy are revealed through the curved light. In this way, the Cosmic Horseshoe is not just a curiosity, it is a tool. By analysing the shape and brightness of the ring, scientists can map the distribution of mass in the foreground galaxy, including dark matter. Dark matter does not emit light, but it contributes most of the gravitational influence. The way the light bends reveals where mass must be present, even if nothing can be seen directly. This makes the Cosmic Horseshoe one of the clearest demonstrations that dark matter is real, structured, and dominant. The ring's smoothness suggests that the mass creating the lens is distributed evenly, without large clumps or disruptions. That smoothness is itself surprising. Many galaxies have messy internal structures, yet here, gravity behaves as if guided by a nearly symmetrical mass distribution. Again, the universe appears calmer and more orderly than expected. There is also a temporal aspect to the Cosmic Horseshoe that is easy to overlook. The light forming the ring left the distant galaxy billions of years ago. It began its journey when the universe was much younger. The foreground galaxy bent that light long after it was emitted, and we receive it now, in a universe that has expanded dramatically since then. What we see is not a single moment, but a layered history. The Cosmic Horseshoe is a fossilized interaction between galaxies separated by vast distances in both space and time. The alignment that created it may no longer exist in the same way. Galaxies move, space expands. The configuration that produced this near-perfect ring may already be dissolving, yet the light preserves it. This adds a quiet emotional weight to the image. The ring looks stable and complete, but it represents a fleeting moment stretched across billions of years. It is a reminder that even the most striking cosmic structures can be temporary, their appearance sustained only by the long travel time of light. Another reason the Cosmic Horseshoe unsettles scientists is how it challenges visual intuition. We are used to associating circular shapes with physical boundaries. Planets are round, rings imply rotation, structures suggest formation mechanisms, but the horseshoe has none of these. There is no spinning ring, no orbiting matter, no structure holding it together. It is space itself doing the shaping. This realization pushes us to reconsider how much of what we see in the universe is real in the way we assume. Many cosmic images are not straightforward photographs. They are projections shaped by gravity, motion, and perspective. The universe we observe is filtered through curved space-time. The Cosmic Horseshoe makes that filtering impossible to ignore. It also quietly reinforces one of the strangest ideas in modern physics: that space is not passive, it is active. It responds to mass. It bends, stretches, and redirects reality itself. In everyday life, space feels empty and inert. In the presence of extreme mass, space becomes dynamic. The horseshoe is space announcing that it has geometry. There is something deeply calming about this idea when approached slowly. The universe is not chaotic in the way noise is chaotic. It follows rules consistently, even when the results surprise us. The cosmic horseshoe exists, not because something went wrong, but because everything behaved exactly as it should. Gravity curved space, light followed. We happened to be in the right place to see it. Nothing more was required. As we sit with this image, it's worth allowing the mind to soften its need for explanation. You don't need to calculate angles or memorize equations. It's enough to recognize that reality is flexible, that space can curve, and that light is willing to follow wherever that curvature leads. The cosmic horseshoe is not shouting a message, it is whispering one. It tells us that the universe is capable of beauty without intention, precision without planning, and symmetry without design. It tells us that what feels impossible is often simply unfamiliar. And most of all, it reminds us that reality does not need to make sense in human terms to be real. It only needs to follow its own rules. As we continue, we'll move deeper into what this rare alignment reveals, not just about gravity and galaxies, but about how the universe quietly demonstrates its most profound truths when we take the time to look slowly. As attention shifts even deeper into what the cosmic horseshoe reveals, its meaning begins to extend beyond gravity and geometry and into something quieter but more unsettling, the way the universe hides truth behind appearance. What we see is rarely what is actually there. The horseshoe does not show us a ring-shaped galaxy. It shows us how perception itself can be reshaped by forces we never feel. In everyday life, vision feels reliable. Light travels in straight lines. Objects appear where they are. Space feels flat and consistent. These assumptions work well on Earth, where gravity is weak and distances are small. But the cosmic horseshoe exists precisely because these assumptions stop working on cosmic scales. Out there, space is not flat. It is sculpted. This means that every deep space image is, in a sense, a translation rather than a photograph. Light carries information, but that information is altered by the terrain it crosses. The cosmic horseshoe is one of the rare moments where the translation becomes visible enough to notice. It exposes the grammar of space-time. What makes this especially important is that gravitational lensing does not merely distort light, it reorganizes it. A single distant galaxy can appear as multiple images, stretched into arcs, mirrored, or wrapped into rings. In some cases, astronomers can see the same object repeated several times around a lensing galaxy, each image representing a different path through curved space. The cosmic horseshoe sits at the extreme end of this phenomenon. Instead of fragmented images, it presents a near-continuous arc, almost closing into a full circle. This continuity gives the illusion of a complete structure where none exists. The mind wants to interpret it as a thing, but it is not a thing. It is a mapping. This distinction matters because it forces us to rethink what it means to observe the universe. When astronomers point telescopes into deep space, they are not seeing objects directly. They are seeing how space-time has allowed light to reach them. Every observation is shaped by gravity along the way. The cosmic horseshoe makes that shaping unmistakable. There is also a deeper implication for how we reconstruct cosmic history. If light paths are curved, then distance, age, and position must be inferred rather than assumed. Astronomers rely on careful modelling to determine where objects truly are and when the light we see was emitted. Gravitational lensing complicates this process, but it also enriches it. By understanding how the light is bent, scientists can reverse engineer the configuration of mass that caused it. The horseshoe becomes a tool not just for seeing far, but for measuring the invisible. This is especially important when studying dark matter. Dark matter does not glow, reflect, or absorb light. Its presence is inferred entirely through gravity. In the cosmic horseshoe, dark matter reveals itself through symmetry. The smoothness of the ring suggests a smooth underlying mass distribution. That smoothness is not guaranteed. Many galaxies show evidence of clumpy dark matter halos, yet here, the lens behaves as though mass is arranged almost perfectly. This raises a quiet question. How common is such order in the universe? The horseshoe hints that, beneath the visible chaos of galaxies, there may be deeper regularities imposed by gravity over time. Interactions, mergers, and motion may gradually smooth mass distributions, producing configurations that feel unexpectedly elegant. In this sense, the cosmic horseshoe may be showing us the long-term tendency of gravity to organize rather than disrupt. This idea runs counter to how we often imagine cosmic evolution. We tend to picture gravity as a force that creates violence, collisions, collapse, destruction. But gravity is also a sculptor. Given enough time, it can produce balance. The horseshoe is gravity in its sculptural mode. There is also a temporal subtlety that becomes more apparent as scientists study lensing in detail. The light forming different parts of the ring may have travelled slightly different distances, passing through different regions of curved space. This means that different segments of the ring may represent slightly different moments in the background galaxy's history. In other words, the horseshoe may be showing us the same galaxy at multiple times simultaneously. This idea is deeply counterintuitive. It suggests that a single image can encode temporal layers compressed into one shape. The universe does not present its history neatly. It folds time into space. The cosmic horseshoe does this gently, without drama. But the implication is profound. It means that when we look at distant objects, we are not just looking back in time. We may be looking sideways through time as well. This challenges the way we think about cosmic chronology. The past is not a single line receding behind us. It is a surface curved and intersected by gravity. The horseshoe offers a glimpse of that surface. Another reason this phenomenon is so powerful is that it does not rely on extreme physics. No exotic particles are required. No speculative theories are invoked. The horseshoe emerges naturally from general relativity, a theory tested countless times across many contexts. This makes its strangeness more unsettling, not less. If ordinary physics can produce such unfamiliar appearances, then the universe may be far more visually deceptive than we assume. There is also a philosophical dimension to this realization. Humans tend to equate reality with appearance. We trust what we see. The cosmic horseshoe undermines that trust gently but decisively. It does not suggest that reality is unknowable. It suggests that reality requires interpretation, and interpretation requires patience. This is where the horseshoe fits beautifully into a slow, reflective exploration of space. It is not a phenomenon that demands reaction. It invites contemplation. You can look at it for a long time and continue noticing new things. The curve of the arc, the subtle variations in brightness, the way it seems to embrace the foreground galaxy without touching it. There is a sense of quiet intimacy between the objects involved, even though they are separated by billions of light years. That intimacy is an illusion, of course, but it feels real. This feeling is important. It reminds us that the universe does not need to be loud or violent to be profound. Some of its deepest lessons arrive wrapped in calm geometry. As scientists refine their models of the cosmic horseshoe, they are also refining their understanding of how often such alignments occur. Each new lens discovered helps build a statistical picture of the universe's structure. Over time, these statistics reveal patterns in how mass is distributed on the largest scales. The horseshoe contributes to this growing map. It also demonstrates the power of chance combined with scale. No single region of space is likely to produce such a perfect lens, but across the entire observable universe, improbability becomes certainty. This reframes how we think about rarity. Rare does not mean unique. It means spread thinly across a vast domain. The universe does not conserve beauty. It distributes it sparsely. There is also an emotional resonance in knowing that the horseshoe was invisible to us until recently. For most of human history, it existed without being seen. It curved light silently, indifferent to observation. Only with modern telescopes did it become visible. This suggests that the universe is filled with structures that are real regardless of recognition. Observation does not create reality, it reveals it. This realization can be strangely comforting. It implies that reality is stable, independent of attention. The universe does not require witnesses. As we continue to explore the Cosmic Horseshoe, we are reminded that the universe often communicates its most important truths indirectly. It does not explain itself. It demonstrates itself. Gravity bends space. Light follows. Geometry shapes perception. The horseshoe is the result. It is not a message sent intentionally. It is a consequence made visible. As we move forward, the horseshoe will continue to serve as both a scientific instrument and a philosophical mirror. It shows us how easily intuition can be bent, how perception depends on structure, and how reality can appear elegant without being designed. For now, it is enough to sit with the image itself, a distant galaxy's light, stretched into a near-perfect curve by the quiet force of gravity. No sound, no motion we can feel. Just a reminder that space is alive with shape, and that shape, when given enough time and distance, can become breathtakingly precise. In the next stretch of this journey, we'll begin to connect the Cosmic Horseshoe to a larger story, one that includes not just individual lenses, but the hidden architecture of the universe itself. As the meaning of the Cosmic Horseshoe continues to unfold, it gradually pulls our attention away from individual galaxies and towards something far larger and more subtle, the hidden architecture of the universe itself. The horseshoe is not just an isolated curiosity, it is a window into the vast invisible framework that shapes everything we see, from the smallest star to the largest clusters of galaxies. To understand this, it helps to imagine the universe not as a random scattering of objects, but as a connected structure. Galaxies are not placed arbitrarily, they follow patterns created by gravity over billions of years. These patterns are not immediately visible because most of the mass responsible for them does not emit light. It exists as dark matter forming an enormous cosmic skeleton. The Cosmic Horseshoe reveals a small but striking piece of that skeleton. When light bends into such a smooth, coherent arc, it tells us that the mass responsible for the bending is itself smooth and coherent. The foreground galaxy is not acting alone. It is embedded in a larger dark matter halo that extends far beyond its visible stars. That halo is part of an even larger network, connected to other halos through filaments of dark matter stretching across intergalactic space. This network is known as the cosmic web. The cosmic web is the universe's large-scale structure, an intricate lattice of filaments, nodes, and voids. Galaxies form along these filaments where dark matter density is highest. Over time, gravity pulls matter inward, strengthening these structures and deepening the wells that guide light. The Cosmic Horseshoe exists because it sits at one of these nodes where mass is concentrated and geometry becomes dramatically curved. In this way, the horseshoe is not just showing us a single galaxy bending light, it is showing us how the cosmic web itself influences perception. The smoothness of the ring suggests that, at least locally, the web has settled into a stable configuration. Chaos has given way to balance. This balance did not arise quickly. It emerged through countless interactions, mergers, and redistributions of mass over cosmic time. Gravity worked patiently, smoothing irregularities and reinforcing dominant structures. What appears elegant now is the result of long, silent evolution. The horseshoe captures the outcome of that evolution. There is something deeply revealing about how much information is encoded in such a simple shape. A ring of light contains clues about dark matter, galaxy formation, cosmic expansion, and the geometry of space. None of this information is visible directly. It must be inferred, decoded, and interpreted. This reinforces an important lesson. The universe communicates indirectly. It does not announce its structure. It leaves traces. The Cosmic Horseshoe is one such trace. Another layer of significance emerges when scientists consider how lensing fits into the broader effort to map the universe. Gravitational lenses act as natural magnifying glasses, allowing astronomers to study distant regions that would otherwise remain beyond reach. In some cases, lensing increases the apparent brightness of background objects by factors of tens or even hundreds. This amplification is crucial for studying the early universe. Many of the most distant galaxies are too faint to observe directly. Lensing brings them into view, stretching their light and revealing details that would be invisible without gravitational assistance. The horseshoe, with its near-perfect symmetry, provides a particularly clean lens. Its geometry simplifies analysis, reducing uncertainty and allowing scientists to extract precise measurements. In this sense, the cosmic horseshoe is both a subject and a tool. It also plays a role in testing fundamental assumptions about gravity. General relativity predicts how mass should bend space-time. By comparing observed lensing patterns with theoretical predictions, scientists can test whether gravity behaves as expected on large scales. So far, the horseshoe confirms Einstein's theory with remarkable accuracy. This confirmation is reassuring, but it also raises new questions. If gravity behaves exactly as predicted, then the unexpected aspects of the horseshoe must arise from distribution rather than law. The mystery shifts from how to why. Why is the mass arranged so smoothly? Why do some regions of the universe produce such clean lenses while others do not? These questions lead deeper into the history of structure formation. The universe began with tiny fluctuations in density. Over time, gravity amplified those fluctuations, pulling matter into clumps. Some clumps merged, others remained isolated. Some regions grew dense quickly while others emptied out, forming vast cosmic voids. The cosmic horseshoe exists at the intersection of these processes. It reflects a region where growth proceeded in a balanced way, avoiding extreme disruption while still accumulating significant mass. This balance is not guaranteed. Many galaxies experience violent mergers that distort their mass distribution. Others are torn apart by interactions with neighbours. The horseshoe's smoothness suggests a relatively calm evolutionary history, at least in terms of mass arrangement. This calmness contrasts with the dramatic imagery often associated with space. Explosions, collisions, and chaos dominate popular imagination. The horseshoe reminds us that quiet processes are just as important. Gravity does most of its work silently. There is also an important implication for how scientists think about cosmic order. The existence of such a precise lens suggests that the universe is not purely stochastic. While chance plays a role, it operates within constraints imposed by physical law and large-scale structure. In other words, randomness is guided. This guided randomness produces patterns that feel meaningful, even though no meaning is intended. The horseshoe is one such pattern. It feels special because it is rare and beautiful, but it is ultimately the natural outcome of many small factors aligning. This perspective can feel both humbling and comforting. It suggests that the universe is neither chaotic nor controlled. It is lawful, expressive, and open-ended. Another subtle aspect of the cosmic horseshoe is how it blurs the boundary between foreground and background. The ring appears to embrace the central galaxy, creating a visual intimacy between objects separated by vast distances. This can create the illusion of interaction where none exists. In reality, the galaxies involved are unaware of one another. Their relationship is purely geometric, yet the image suggests connection. This illusion highlights how much meaning humans project onto cosmic images. We instinctively look for relationships, narratives, and structures. The universe provides shapes that invite interpretation, even when no interaction occurs. The horseshoe is a reminder to distinguish between visual association and physical interaction. There is also a lesson here about humility in observation. Even when we see something clearly, understanding requires careful analysis. The horseshoe looks simple, but its simplicity is deceptive. Beneath the curve lies a complex interplay of mass, geometry, and time. This interplay cannot be grasped at a glance. It rewards slow study. That slowness aligns beautifully with the nature of the phenomenon itself. The horseshoe was not created quickly. It is the product of billions of years of cosmic motion. It feels appropriate to approach it with patience. As scientists continue to catalogue gravitational lenses, they are building a statistical picture of the universe's mass distribution. Each lens adds a data point. Over time, patterns emerge. Regions of higher density, preferred alignments, and correlations between visible and invisible matter become clearer. The horseshoe contributes disproportionately to this effort because of its clarity. It also serves as a benchmark. By studying such a clean system, scientists can calibrate their models and refine their techniques. This improves analysis of messier lenses elsewhere. In this way, a single rare object helps unlock understanding across the universe. There is something quietly profound about that. One near-perfect alignment, occurring by chance, becomes a key to interpreting countless others. This echoes a broader truth about science. Insight often comes from exceptions. The unusual reveals the underlying rule. The cosmic horseshoe is unusual enough to be memorable, but not so extreme as to defy explanation. It occupies a sweet spot where mystery and understanding coexist. As we sit with this idea, it becomes clear that the horseshoe is not an endpoint. It is a bridge. It connects observation to theory, beauty to physics, intuition to reality. It also invites a shift in perspective. Instead of seeing the universe as a collection of isolated objects, we begin to see it as a continuous geometry shaped by mass and motion. Galaxies are not just things in space, they are expressions of space. The horseshoe makes that expression visible. As this exploration continues, the focus will gradually widen even further, moving beyond individual lenses and into the question of how common such hidden geometries may be. The universe may be filled with subtle distortions waiting to be noticed. For now, the cosmic horseshoe stands as a reminder that the universe often reveals its deepest structure not through force or spectacle, but through quiet alignment, a curve of light, a smooth arc, a silent demonstration of how space itself bends reality into shape. As the cosmic horseshoe settles into our understanding, attention naturally drifts toward a deeper question, one that feels less technical and more philosophical, yet is inseparable from the physics itself. Why does a structure like this feel so striking to us? Why does a curved ring of light formed unintentionally by gravity seem to carry a sense of meaning, harmony, or even intention, despite being the result of impersonal forces? Part of the answer lies in how human perception evolved. Our minds are tuned to notice symmetry, continuity, and balance. These traits once helped our ancestors identify faces, movements, and threats in complex environments. When the universe accidentally produces a shape that echoes these qualities, it triggers the same deep cognitive response. The cosmic horseshoe feels special not because it was designed, but because it resonates with how we recognize order. Yet the universe does not care whether we notice it. The forces that shaped the horseshoe operated long before minds existed to interpret them. Gravity did not aim to produce elegance. It followed its rules without awareness, slowly guiding matter into positions where geometry unfolded into something visually extraordinary. This realization carries a subtle but powerful lesson. Beauty in the universe is not a goal, it is a byproduct. The horseshoe exists because space and time are flexible, because mass curves geometry, and because light follows the shortest possible paths through that curved geometry. When those rules intersect in just the right way, beauty emerges unintentionally. This accidental beauty challenges the way we think about complexity. Many assume that complexity requires intention or design, but the horseshoe shows that complexity can arise from simplicity, provided enough time and scale. The rules of gravity are simple. The outcome, when extended across billions of light years and billions of years, becomes intricate and surprising. This principle applies far beyond gravitational lensing. Galaxies spiral without guidance. Stars organize themselves without direction. Even the large-scale structure of the universe, the vast filaments and voids, emerges from small fluctuations amplified by gravity. No central planner exists. The universe organizes itself through persistence. The Cosmic Horseshoe is a frozen moment in that self-organization. Another layer of meaning emerges when considering how fragile such alignments are. A slight shift in position, a small difference in mass distribution, or a tiny change in distance would dissolve the ring entirely. The background galaxy would appear distorted, stretched, or multiplied into arcs instead of a clean circle. The horseshoe exists on a razor's edge of geometry. This fragility highlights an important truth about cosmic observation. What we see is only one of countless possibilities. The universe contains an enormous range of configurations, most of which we will never witness. Our view is limited not just by technology, but by circumstance. The horseshoe reminds us that observation is selective. We see what happens to align with us. That realization encourages humility. Even when we believe we understand the universe, we are only sampling a tiny fraction of its full expression. Countless phenomena unfold beyond our line of sight, unseen and unrecorded. Yet the ones we do observe can still reshape understanding. Gravitational lenses like the Cosmic Horseshoe have played a quiet but transformative role in modern cosmology. They have helped confirm the existence of dark matter, refine measurements of cosmic expansion, and probe the structure of distant galaxies. None of this was obvious when Einstein first proposed that gravity could bend light. At the time, the idea seemed almost abstract. Light was thought to be massless and untouchable. The notion that gravity could curve its path challenged intuition. Even Einstein reportedly doubted that such effects would ever be observed. The horseshoe proves how wrong that doubt was. It also illustrates how theory and observation dance together. Theory predicts possibilities. Observation reveals which possibilities are realized. Sometimes observation surprises theory, not by breaking it, but by revealing its full implications. The horseshoe does exactly that. It doesn't contradict relativity. It demonstrates how far-reaching relativity truly is. There is also a temporal dimension to consider. The light forming the horseshoe has travelled for billions of years. When we observe it, we are not seeing the galaxies as they are now, but as they were long ago. The lens itself existed in a different cosmic era. The background galaxy emitted its light at an even earlier time. The horseshoe is therefore a composite image of multiple epochs. This layering of time complicates interpretation. The shape we see is not just a spatial alignment, but a temporal one. Light from different periods arrives simultaneously, compressed into a single image. In this sense, the horseshoe is a kind of time sculpture. It captures motion, history, and geometry in a single frame. The galaxies involved may have changed dramatically since the light left them. Some stars may no longer exist. Structures may have evolved, yet their past remains visible. This realization deepens the sense of quiet awe surrounding the phenomenon. The horseshoe is not just bending space, it is folding time into our perception. Another aspect worth lingering on is how rare it is for the universe to present its workings so clearly. Much of cosmic physics must be inferred indirectly. Dark matter cannot be seen. Dark energy reveals itself only through its effects. Even black holes announce themselves through shadows and distortions rather than direct observation. The horseshoe, by contrast, is visually explicit. It shows curvature openly. This openness makes it pedagogically powerful. It allows scientists to communicate abstract ideas using tangible imagery. A curved ring is easier to grasp than equations describing space-time metrics. Yet there is a danger in that clarity. Visual simplicity can mask conceptual depth. The horseshoe may look easy to understand, but its full interpretation requires careful modelling, assumptions about mass distribution and precise measurements. This tension between appearance and explanation mirrors a broader challenge in science communication. Images attract attention, but understanding requires patience. The horseshoe rewards that patience. It invites slow contemplation, much like the phenomenon itself unfolded slowly. Gravity did not rush to create it. The alignment emerged gradually as galaxies moved through space. The light travelled unhurriedly, following geodesics shaped by mass. There is something fitting about approaching it with the same calm. As we reflect on the horseshoe's place in the universe, it becomes clear that it occupies a unique intersection of science and wonder. It is rigorous enough to support precise measurement, yet evocative enough to inspire reflection. This dual role is rare. Many scientific discoveries are either technically important or emotionally resonant. The horseshoe manages to be both. It advances understanding while also offering a visual metaphor for the universe's flexibility. Space is not rigid, time is not absolute, light does not always travel straight. These truths are not new, but the horseshoe makes them feel real. It also subtly shifts our sense of scale. When we see light bent into a ring by a galaxy, we are reminded that galaxies themselves are not isolated islands. They are embedded in a continuous fabric that responds to mass. This fabric connects everything, from the smallest particle to the largest cluster. All matter participates in shaping space-time. The horseshoe is simply one of the few places where that participation becomes visible. In quiet moments, contemplating this can feel grounding. It reframes existence not as a collection of separate objects, but as a unified process. Everything influences everything else, even if the influence is subtle. The horseshoe does not shout this message, it whispers it. As the exploration deepens, attention naturally turns toward how many other hidden geometries might exist beyond our current surveys. The universe is vast, our catalogues are incomplete. For every horseshoe we have found, countless others may exist unseen. Some may be more distorted, others may be more perfect. Some may never align with Earth at all. The universe is full of potential shapes that will never be observed. This thought carries both melancholy and comfort. Melancholy because so much remains unseen. Comfort because the unseen does not diminish what is known. The horseshoe stands as evidence that the universe is capable of surprising us gently, without drama or violence. Sometimes it reveals itself through quiet precision. As this section settles, the cosmic horseshoe remains suspended in space, not just as an object, but as an idea that gravity is not merely a force, but a sculptor. An idea that light is not merely illumination, but a messenger shaped by geometry. An idea that reality is more flexible, more subtle, and more patient than everyday experience suggests. And in that patience, the universe leaves behind moments of accidental beauty, waiting for us to notice, slowly. As the quiet implications of the cosmic horseshoe continue to settle, another realization gradually takes shape, one that shifts the focus away from what we see and toward how much we cannot see. The horseshoe is not remarkable only because it bends light into a near-perfect ring, but because it reveals the overwhelming influence of things that remain invisible. Most of the mass responsible for this phenomenon does not shine, glow, or emit radiation of any kind. It exists silently, shaping reality without ever announcing itself. This unseen influence is dark matter. Without dark matter, the cosmic horseshoe would not exist in its observed form. The visible stars of the foreground galaxy do not provide enough mass to bend light so dramatically. The smoothness, symmetry, and strength of the lens require a massive halo of dark matter enveloping the galaxy, extending far beyond its luminous boundaries. In a sense, the horseshoe is a portrait of something we cannot photograph directly. Dark matter does not interact with light, but it interacts strongly with gravity. This makes gravitational lensing one of the most powerful tools for studying it. Where light bends, mass must exist. Where rings and arcs appear, dark matter must be shaping space. The horseshoe therefore functions as a kind of cosmic fingerprint. Its shape encodes information about how dark matter is distributed, not just how much there is, but how smoothly it spreads, how concentrated it becomes, and how it behaves on galactic scales. What makes this particularly striking is how orderly that invisible structure appears. Dark matter is often imagined as chaotic or turbulent, but the horseshoe suggests otherwise. At least in this region, dark matter has settled into a calm, stable configuration. It forms a halo that is symmetrical enough to produce an almost perfect ring. This challenges simplistic assumptions about cosmic disorder. The universe is often portrayed as violent and unpredictable, filled with explosions, collisions, and extreme events. While those do occur, much of cosmic evolution is slow, gentle, and stabilizing. Over long periods, gravity smooths irregularities. Systems relax into equilibrium. The horseshoe reflects that relaxation. It tells a story of patience. Dark matter halos form gradually, growing through mergers and accretion. Over time, their internal motions settle, substructures dissolve. What remains is a coherent mass distribution capable of shaping space-time with precision. This patience is difficult to grasp from a human perspective. Our lives unfold over decades. Galaxies evolve over billions of years. Dark matter halos persist across cosmic history, largely unchanged once they reach maturity. The horseshoe is a snapshot of that maturity. Another important insight emerges when scientists analyze subtle imperfections in the ring. While it appears smooth at first glance, careful measurements reveal slight variations in brightness and curvature. These imperfections are not flaws in observation. They are signatures of smaller clumps of dark matter embedded within the halo. These clumps are known as subhalos. Subhalos are remnants of smaller structures that merged into the larger halo over time. They are invisible on their own, but their gravitational influence distorts light locally, creating small deviations in the lensing pattern. By studying these deviations, scientists can infer the existence and properties of dark matter on small scales. This is crucial because different theories of dark matter predict different levels of clumpiness. Some models suggest dark matter should form many small substructures, others predict smoother distributions. The Cosmic Horseshoe provides a testing ground for these ideas. In this way, a quiet arc of light becomes a laboratory for fundamental physics. What is particularly elegant about this method is that it relies purely on gravity. No assumptions about particle interactions are required. Light bends or it does not, space curves or it does not. The evidence is geometric. Geometry becomes a language for the invisible. This geometric approach also sidesteps some of the limitations of other dark matter detection methods. Direct detection experiments search for rare interactions between dark matter particles and ordinary matter. These experiments are challenging and uncertain. Lensing, by contrast, observes dark matter's collective gravitational effect, which cannot hide. The horseshoe therefore strengthens confidence in dark matter's role in cosmic structure, even if its nature remains unknown. Yet this confidence does not eliminate mystery. On the contrary, it deepens it. We know dark matter exists. We know it shapes galaxies and bends light, but we still do not know what it is made of. The horseshoe reminds us that understanding can be partial and still powerful. There is also a subtle shift in perspective that occurs when contemplating dark matter through lensing. Instead of viewing dark matter as an exotic add-on to the universe, it begins to feel like the primary component. Ordinary matter, the stars, planets, and gas, is the exception, not the rule. Most of the universe's mass is dark. From this perspective, the luminous galaxy at the center of the horseshoe is more like a tracer, highlighting the presence of something much larger and more dominant. The visible is riding on the invisible. This inversion can be unsettling. It challenges intuitive ideas about substance and reality. What we see is not what matters most gravitationally. Yet this is consistent with other areas of physics. Atoms are mostly empty space. Forces act through fields we cannot see. Reality is often structured by what is not directly perceptible. The horseshoe fits comfortably into this pattern. Another layer of meaning emerges when considering how lensing connects distant regions of the universe. The background galaxy whose light forms the ring exists far beyond the lensing galaxy. The two are separated by enormous distances and cosmic time, yet their interaction is intimate. Light from the background galaxy does not simply pass by the foreground galaxy. It is guided, redirected, and reshaped by it. The foreground galaxy becomes part of the background galaxy's image. This creates a visual entanglement across space and time. Such entanglement is not physical in the sense of interaction or exchange, but it is relational. The appearance of one object depends on the presence of another. Observation becomes contextual. This idea resonates with broader themes in modern physics where context matters deeply. Measurements depend on frames of reference. Observations depend on geometry. Nothing exists in isolation. The horseshoe embodies this relational reality. It also invites reflection on the role of alignment in discovery. The horseshoe was not created for us. It exists because of chance alignment. Earth happens to lie along a line of sight where geometry produces this effect. If Earth were slightly displaced, the horseshoe would not appear as it does. This highlights the contingent nature of observation. Many profound cosmic phenomena may exist, but only a fraction align in ways we can detect. Our cosmic perspective is privileged in some ways and limited in others. The horseshoe is a gift of alignment. This gift also comes with responsibility. Interpreting it requires care. Lensing models must account for uncertainties in distance, mass distribution, and cosmic expansion. Assumptions must be tested, conclusions must be revised as data improves. The apparent perfection of the ring does not guarantee simple interpretation. In fact, the very smoothness that makes the horseshoe striking can mask complexity. Different mass distributions can sometimes produce similar lensing patterns. Distinguishing between them requires additional data and careful modelling. This reminds us that even clear images can be ambiguous. Yet ambiguity is not a flaw. It is an invitation to refine understanding. Science advances not by eliminating uncertainty, but by constraining it. The horseshoe contributes to that constraint. As observations improve, especially with next-generation telescopes, similar lenses will be discovered and studied in greater detail. Statistical samples will grow, patterns will emerge. The role of dark matter will become clearer, even if its nature remains elusive. The horseshoe is part of that unfolding story. There is also a quiet, emotional dimension to contemplating invisible mass shaping visible light. It evokes a sense of trust in unseen structure. The universe operates according to principles that do not require visibility to be effective. This can be strangely comforting. It suggests that reality is supported by deeper layers that persist regardless of observation. The horseshoe does not depend on us noticing it. As this section comes to rest, the cosmic horseshoe stands revealed not just as a curiosity, but as evidence of a hidden order, an order that operates silently, patiently, and consistently across cosmic time. Light curves, space responds, mass remains unseen but undeniable. And in that quiet interaction, the universe reveals that what matters most is not always what shines, but what holds everything together. As the deeper implications of the cosmic horseshoe continue to unfold, attention slowly shifts from structure and substance towards something even more subtle, what the horseshoe teaches us about perspective itself. Not just scientific perspective, but the way reality changes depending on where you observe it from, how you observe it, and what assumptions you bring with you when you look. The cosmic horseshoe exists only because of perspective. From most locations in the universe, it would not appear as a ring at all. The background galaxy would look ordinary. The foreground galaxy would look unremarkable. Nothing about either object would suggest something extraordinary was happening. Only from Earth, only along this precise line of sight, does the geometry align in such a way that space reveals its curvature so clearly. This means the horseshoe is not an intrinsic shape. It is a relationship. That idea is easy to overlook. We tend to think of cosmic objects as having fixed appearances. Galaxies are spirals, stars are points, nebulae are clouds. But gravitational lensing reminds us that appearance is conditional. What something looks like depends on how space-time between you and it is shaped. In other words, the universe does not present a single objective image. It presents many possible images, and we see only one of them. This realization quietly undermines the idea of a true cosmic view. There is no universal camera angle. There is no privileged frame where reality reveals itself fully. Every observation is partial, shaped by geometry and motion. The horseshoe is a perfect example of this limitation. From another galaxy, observers would see the same system entirely differently. The ring might collapse into an arc, the arc might split into multiple images, or the lensing might disappear entirely. The dramatic symmetry we see is not a property of the universe as a whole, it is a property of our viewpoint. This does not make the horseshoe less real, it makes it more instructive. It reminds us that understanding the universe requires humility. We must always ask, what am I seeing because it exists, and what am I seeing because of where I am? This question extends far beyond lensing. It applies to cosmic expansion, background radiation, even the apparent distribution of galaxies. Many of the universe's most important discoveries depend on recognizing how perspective shapes observation. The cosmic horseshoe trains us in this recognition. Another layer of perspective emerges when considering time. The alignment that produces the horseshoe is temporary. Galaxies are moving, space is expanding. Over millions of years, the geometry will change enough that the ring dissolves. The horseshoe is therefore a fleeting configuration. From a human standpoint, millions of years feels eternal. From a cosmic standpoint, it is a brief moment. The horseshoe exists in a narrow window of time when distances, positions, and mass distributions align just right. This temporal fragility reinforces the idea that cosmic beauty is often transient. The universe does not preserve symmetry, it passes through it. The ring we see now did not exist in the distant past, and it will not exist in the far future. It is a momentary expression of deeper laws. This makes the horseshoe feel less like an object and more like an event. Yet, unlike explosive cosmic events, supernovae, gamma-ray bursts, the horseshoe unfolds slowly and quietly. Nothing dramatic happens when it forms. No energy is released, no matter is destroyed. Space simply curves, and light follows. This quietness is important. It challenges the assumption that significance requires violence or intensity. Some of the universe's most profound demonstrations of its nature occur without spectacle. The horseshoe teaches through restraint. Another perspective shift arises when considering scale. The ring looks large and dramatic in images, but it is composed of light from a galaxy so distant that its individual stars cannot be resolved. Each bright arc contains countless stars, gas clouds, and structures compressed into a thin curve. What looks simple is immensely complex. This compression of complexity into a clean shape mirrors how much of science operates. We reduce systems to symbols, graphs, and equations. We compress reality to understand it. The horseshoe is nature doing that compression visually. It is a reminder that simplicity often hides depth. This depth becomes even more apparent when scientists reconstruct the original appearance of the background galaxy. By modeling the lens, they can mathematically unwrap the ring and infer what the galaxy would look like without distortion. The result is often surprising. Galaxies revealed through lensing can appear irregular, clumpy, and turbulent, especially in the early universe. Star formation can be intense and uneven. Structures may be chaotic rather than orderly. The smoothness of the ring contrasts sharply with the roughness of the source. This contrast reinforces an important idea. The universe does not privilege neatness. The neatness we observe is often imposed by geometry, not by the underlying object. The horseshoe is neat because space-time smooths light's path, not because the galaxy itself is simple. This has implications for how we interpret cosmic imagery. Beautiful images can mislead if we assume they reflect intrinsic order. Sometimes beauty is an artifact of perspective. The horseshoe invites us to look past appearances. Another subtle lesson lies in how gravitational lensing blurs the distinction between foreground and background. The foreground galaxy becomes part of the background galaxy's image. The two are visually intertwined, even though they are separated by billions of light years. This visual merging challenges linear thinking. We are used to thinking in layers: foreground, middle ground, background. Lensing collapses those layers. Light from different depths arrives together. Time and space overlap. The horseshoe demonstrates that cosmic depth is not always visually obvious. This collapsing of depth also echoes how modern cosmology understands the universe. Space and time are not separate arenas. They are unified into spacetime. Events that seem distant in time can be adjacent in observation. The horseshoe embodies this unity. There is also a quiet epistemological lesson here. Much of what we know about the universe comes not from direct observation, but from interpreting distortions. We infer mass from motion, expansion from redshift, structure from lensing. We learn by watching how reality deviates from expectation. The horseshoe is a deviation made visible. Light should travel straight. When it doesn't, something must explain the deviation. That explanation leads us to curved spacetime, dark matter, and cosmic structure. In this way, the horseshoe reinforces a broader truth. The universe reveals itself most clearly where intuition fails. It is at the edges of expectation that understanding deepens. This makes the horseshoe an ideal object for reflection rather than just measurement. It invites us to slow down, question assumptions, and accept that reality may not align with everyday experience. Such acceptance is not resignation. It is openness. The horseshoe does not invalidate common sense, it expands it. There is also an emotional resonance to this expansion. Seeing a perfect ring formed by gravity alone can evoke a sense of calm. The universe appears balanced, coherent, and lawful. Even its strangest behaviors follow rules. For some, this is comforting. For others, it is unsettling. The same phenomenon can inspire awe or discomfort depending on perspective. The horseshoe accommodates both responses. It does not insist on interpretation. It simply exists, curved quietly by mass and geometry. As this section draws to a gentle close, the cosmic horseshoe remains suspended as a lesson in perspective. It teaches that reality is relational, that observation is conditional, and that understanding requires awareness of one's own viewpoint. The universe does not present itself plainly. It offers hints, distortions, and alignments. And when those alignments briefly converge, when light curves into a ring and space reveals its flexibility, we are given a chance to glimpse not just how the universe works, but how deeply our perception is woven into what we call reality. The horseshoe does not ask us to be impressed. It asks us to look carefully. As attention drifts further into the meaning of the cosmic horseshoe, a quieter realization begins to emerge, one that has less to do with equations or models and more to do with how the universe communicates complexity through simplicity. The horseshoe does not overwhelm the senses. It does not erupt or collide or explode. It presents itself as a single calm gesture, a curve of light. And yet, that gesture contains layers of information that stretch across physics, cosmology, and human understanding. There is something instructive about how much the horseshoe reveals while appearing to do almost nothing at all. In everyday experience, change is usually associated with motion. Objects move, systems shift, energy is transferred. But the horseshoe demonstrates a different kind of change, one that occurs without movement in the usual sense. The galaxies involved continue their slow journeys through space, but the phenomenon itself arises from geometry rather than action. Nothing dramatic happens to create the ring. No force is applied suddenly. No event triggers it. The horseshoe exists because space is already curved, and light simply follows that curvature. This introduces a subtle but profound idea. Some of the universe's most important behaviors are passive. They are not reactions, but conditions. Gravity does not need to push light. It only needs to shape the environment through which light travels. This distinction matters. Much of human thinking is built around cause and effect. One thing striking another. one action producing a reaction. The horseshoe operates differently. There is no direct interaction between the foreground galaxy and the background light in the usual sense. The galaxy does not touch the light, it does not deflect it actively. It merely exists with mass, and that existence is enough. This passive influence is a recurring theme in cosmology. Dark energy shapes the expansion of space without exerting force in a traditional sense. Space-time curvature guides motion without requiring contact. The horseshoe is a visual lesson in how presence alone can shape outcome. Presence is power. Another quiet insight emerges when considering how the horseshoe changes our relationship with distance. Normally, distance implies separation. The farther away something is, the less influence it has on us. But gravitational lensing collapses that intuition. A galaxy billions of light years away can determine how we see another galaxy even farther beyond it. Distance does not eliminate influence. It merely transforms it. This challenges the assumption that the universe becomes less connected at larger scales. In reality, large-scale structure creates new forms of connection. Light from the distant universe carries the imprint of everything it passes near. The horseshoe shows that the universe remembers what light encounters. Every curve in the ring is a record. Every brightness variation encodes mass. The image is not just a picture, it is a history of interaction written into geometry. This makes the horseshoe feel almost archival. It preserves information about the universe that would otherwise be inaccessible. Without lensing, the background galaxy would be too faint, too distant, too small to study in detail. The foreground galaxy becomes an accidental archivist, magnifying and preserving that distant light. This accidental preservation highlights another recurring theme. The universe often reveals itself indirectly. We do not observe the earliest galaxies directly. We observe their light after it has been shaped, stretched, and filtered by everything in between. The horseshoe is a reminder that observation is always mediated. This mediation is not a flaw, it is an opportunity. By studying how light is altered, scientists can reconstruct what lies behind the alteration. The distortion becomes data, the curve becomes a clue. In this sense, the horseshoe turns imperfection into insight. It also invites reflection on the limits of clarity. While the ring appears clean and complete, it is still an approximation. No image captures the full complexity of the system. There are uncertainties in distance, mass distribution, and cosmological parameters. Even the most beautiful lens is still interpreted through models. This is not a weakness of science, but a condition of it. Knowledge advances through refinement, not certainty. The horseshoe contributes to that refinement by narrowing possibilities and eliminating implausible models. It does not provide final answers. It improves questions. There is also a quiet lesson here about patience. Understanding the horseshoe required decades of theoretical development, technological progress, and observational refinement. Einstein predicted light bending in 1915. The first gravitational lens was confirmed in 1979. High-resolution lenses like the horseshoe came even later. Discovery unfolded slowly. This slow unfolding contrasts sharply with modern expectations of immediacy. We are accustomed to rapid results and instant explanations. The horseshoe resists that pace. It invites lingering attention. Its meaning deepens the longer it is studied. This makes it particularly well suited to contemplation rather than consumption. The horseshoe does not reward skimming, it rewards stillness. Another subtle dimension arises when considering how rare such near-perfect lenses are. The universe contains billions of galaxies, yet only a small fraction produce lensing effects visible from Earth. Of those, even fewer align well enough to create near-complete rings. The horseshoe is statistically unlikely. This rarity enhances its value. Not because rarity implies importance, but because rarity provides leverage. Uncommon configurations stretch theories, test assumptions, and expose edge cases. The horseshoe is an edge case that behaves beautifully. Edge cases are often where understanding improves most rapidly. They reveal what models can and cannot handle. They expose hidden assumptions. They force clarity. In that sense, the horseshoe is not just a curiosity. It is a stress test for cosmology. It asks whether our understanding of gravity, mass distribution, and cosmic structure holds up under precise alignment. So far, the answer appears to be yes, but with nuance. That nuance matters. It suggests that while our fundamental theories are robust, the universe still contains details that require refinement. Dark matter may be smoother or clumpier than expected. Galaxy evolution may follow multiple pathways. Structure formation may involve subtleties not fully captured in simulations. The horseshoe quietly hints at these possibilities without shouting. There is also an aesthetic dimension that deserves attention, not as decoration, but as information. The symmetry of the ring is not arbitrary, it reflects the underlying symmetry of the mass distribution. Beauty here is diagnostic. When symmetry appears, it often signals stability. When symmetry breaks, it signals disturbance. The horseshoe's smooth arc suggests a system that has settled. This interpretation aligns with broader physical principles. Systems tend toward configurations that minimize energy. Over time, chaotic motion dampens. Equilibrium emerges. The horseshoe may represent a local equilibrium in space-time curvature. This equilibrium is not static. It persists only as long as conditions allow. But while it lasts, it provides a clean window into the laws shaping it. There is something reassuring about this. It suggests that even in a vast, evolving universe, moments of balance arise naturally. The horseshoe is one such moment. As reflection continues, it becomes clear that the horseshoe occupies a unique emotional space. It is not terrifying like a black hole, nor explosive like a supernova. It is gentle. It bends rather than breaks. This gentleness does not diminish its significance, it enhances it. It shows that the universe does not need extremes to demonstrate its depth. Subtle curvature is enough. This can influence how we relate to the cosmos. Instead of focusing only on the most dramatic events, we can appreciate the quiet demonstrations of law and structure that occur continuously. The horseshoe invites that shift. It asks us to notice the slow, the subtle, and the indirect. As this section settles, the cosmic horseshoe remains what it has always been, a calm arc of light shaped by invisible mass. But layered within that arc are lessons about patience, perspective, mediation, and presence. It teaches that the universe often speaks softly, and that listening carefully to curves, distortions, and alignments can reveal truths just as profound as any explosion or collision. In the end, the horseshoe does not demand interpretation. It simply curves light, and in doing so, allows reality to explain itself, quietly, precisely, and without urgency. As the cosmic horseshoe continues to reveal its layers, the focus naturally drifts toward one of the most quietly unsettling ideas it carries. The universe is constantly reshaping reality without ever announcing that it is doing so. The horseshoe does not signal a special event. It does not erupt into existence. It does not mark a beginning or an end. It simply is, a consequence of conditions that have been present all along. This realization can feel disorienting. We tend to imagine the universe as a place where important things happen at specific moments, explosions, collisions, births, deaths. But the horseshoe exists outside that narrative. It is not an event in time. It is a condition in space, and conditions can persist quietly for immense stretches of cosmic history. The universe, in this sense, is less like a story and more like a landscape. The horseshoe belongs to that landscape. It is a valley carved not by sudden force, but by slow, persistent pressure. Gravity worked patiently, shaping space-time over billions of years until light naturally followed a curved path. No decision was made. No threshold was crossed. The geometry simply allowed it. This challenges how humans instinctively search for causes. We want to know what happened to make the horseshoe appear, but nothing happened. There was no trigger. The ring exists because nothing prevented it from existing. That idea, existence without cause in the usual sense, can feel unsettling, but it reflects a deeper truth about the universe. Many of its most important features arise from constraints, not actions. The laws of physics set boundaries. Within those boundaries, outcomes emerge naturally. The horseshoe is one such outcome. Another layer of meaning emerges when considering how gravitational lensing alters not just images but expectations. Before lensing was understood, astronomers assumed light always travelled straight. Observations were interpreted accordingly. When images appeared distorted, they were often dismissed as errors or anomalies. The horseshoe represents a shift in mindset. It reminds us that reality does not conform to intuition. Intuition must be revised to conform to reality. This is a recurring theme in the history of science, but it is rarely demonstrated so clearly. A perfect ring of light should not exist if space were flat. The horseshoe exists because space is not flat. This simple statement carries enormous implications. It means that geometry itself is dynamic. It responds to mass. It bends, stretches, and warps. The universe is not a static stage on which events unfold. It is an active participant. The horseshoe makes that participation visible. Another subtle insight arises when we consider how the horseshoe complicates the idea of location. Where is the ring? Is it at the foreground galaxy? Is it at the background galaxy? Is it somewhere in between? The answer is uncomfortable. It is nowhere and everywhere along the light's path. The ring is not a physical object. It cannot be touched. It cannot be isolated. It exists only as an image formed by curved space-time. Remove the observer and the ring disappears, not because the physics changes, but because the image has no meaning without observation. This does not mean the phenomenon is subjective. The curvature is real. The mass is real, but the ring as a shape is relational. This challenges how we define reality. Many things we treat as objects are actually relationships. Temperature is a relationship between energy and matter. Color is a relationship between light and perception. Even time is a relationship between motion and measurement. The horseshoe fits into this pattern. It is a relationship between mass, light, and viewpoint. This relational nature becomes even more apparent when considering that the same system can produce multiple images depending on alignment. Some lenses create double images, others create arcs, others create partial rings. The underlying mass distribution may be similar, but the outcome differs. Reality is not fixed, it is conditional. This conditionality does not undermine scientific truth. It refines it. Instead of asking what is it, science increasingly asks under what conditions does it appear. The horseshoe exists under very specific conditions. Another quiet lesson emerges when considering how gravitational lensing blurs the boundary between measurement and interpretation. To extract information from the horseshoe, scientists must model the mass distribution of the lensing galaxy. These models involve assumptions, constraints, and approximations. The data does not speak for itself. This is not a flaw. It is a feature of complex systems. Understanding emerges from an interaction between observation and theory. The horseshoe sits at that intersection. It reminds us that scientific images are not raw reality. They are processed, interpreted, and contextualized. The beauty we see is filtered through understanding. This does not make the image less meaningful, it makes it richer. Another dimension to consider is how the horseshoe reframes the concept of distance. Normally, distance implies separation and isolation, but lensing shows that distant objects can influence each other's appearance profoundly. The background galaxy's image is shaped by a galaxy billions of light years closer to us. That influence travels through space-time, not through direct interaction. This suggests a universe that is deeply interconnected, even across vast distances. Yet this interconnectedness is subtle. It does not imply communication or awareness. It is structural, not intentional. The universe connects things through geometry, not through purpose. The horseshoe embodies this kind of connection. There is also an important psychological effect to consider. When humans see such precise cosmic structures, there is a temptation to attribute meaning or intention. The ring looks too perfect to be accidental, but the horseshoe gently dismantles that impulse. Its perfection is statistical, not purposeful. Given enough galaxies, enough time, and enough lines of sight, rare alignments will occur. The universe does not aim for perfection, it samples possibilities. This realization can feel humbling. It suggests that our presence is not central to the universe's order. The horseshoe was not created for us to admire. It exists because physical laws allow it. Yet this does not diminish its significance. On the contrary, it enhances it. The fact that such beauty can arise without intention speaks to the richness of the universe's underlying rules. Another layer of reflection emerges when considering how lensing images compress information. The horseshoe contains data about mass, distance, expansion, and structure, all encoded in a single shape. This compression mirrors how the universe itself operates. Vast complexity emerges from simple rules applied repeatedly. The horseshoe is complexity made visible. It also invites a reconsideration of what counts as extreme in space. Often, extremes are associated with energy, violence, or scale. The horseshoe is extreme in a different way. It is extreme in precision. Perfect alignment is rare. Smooth mass distribution is rare. Clean lensing geometry is rare. The horseshoe is an extreme example of order rather than chaos. This expands the vocabulary of cosmic extremes. The universe is not only extreme in its power, but in its subtlety. As contemplation deepens, the horseshoe begins to feel less like an anomaly and more like a quiet ambassador of deeper principles. It represents how geometry governs behavior, how invisibility does not imply insignificance, and how observation is inseparable from perspective. It also reminds us that not all discoveries announce themselves loudly. Some arrive as gentle curves that slowly reshape understanding. The horseshoe does not demand urgency. It does not threaten or overwhelm. It invites patience, and patience is essential when dealing with a universe that operates on timescales far beyond human experience. As this reflection settles, the cosmic horseshoe remains suspended not just in space, but in thought. It stands as a reminder that reality is not always found in objects, events, or boundaries. Sometimes reality reveals itself in relationships, a curve of light, an invisible mass, a precise alignment. And in that alignment, the universe quietly reminds us that what we see is shaped not only by what exists, but by how existence allows itself to be seen. As the cosmic horseshoe continues to settle into understanding, a deeper and more reflective realization begins to take shape. One that reaches beyond astronomy and into the nature of knowledge itself. The horseshoe quietly demonstrates that the universe does not explain itself directly. Instead, it leaves traces, distortions, and patterns that must be interpreted slowly, carefully, and with restraint. What we see is never the whole story. The horseshoe is not a message sent toward Earth. It is not a signal designed to be understood. It is a consequence. And yet, within that consequence lies an extraordinary amount of information. This forces a shift in how we think about discovery. The universe does not reveal truths by presenting answers. It reveals them by allowing reality to bend in observable ways. In this sense, gravitational lensing becomes a form of cosmic language, not a language of words or symbols, but of curvature, symmetry, and deviation. The horseshoe is a sentence written in space-time. Learning to read that sentence requires abandoning many everyday assumptions. We must accept that space is not empty, time is not uniform, and distance does not isolate. We must accept that light, which feels fundamental and constant, is itself shaped by its surroundings. This acceptance does not come naturally. It requires mental stillness. The horseshoe rewards that stillness. It does not yield its meaning quickly. The longer it is examined, the more it reveals, not because it changes, but because our understanding does. Another important realization emerges when we consider how much trust we place in indirect evidence. No one has ever touched dark matter. No one has observed space-time curvature directly with their senses. And yet, through phenomena like the horseshoe, we trust these concepts enough to build entire models of the universe around them. This trust is not blind. It is earned. The horseshoe earns it through consistency. Its geometry aligns with predictions. Its distortions match calculations. Its behavior repeats across other lensing systems. Each observation reinforces confidence that the underlying explanation is correct. This reinforces a subtle truth. Certainty in science does not come from direct experience, but from convergence. When many independent lines of evidence point in the same direction, understanding stabilizes. The horseshoe contributes to that convergence. At the same time, it reminds us that convergence is never final. Models improve, measurements refine, interpretations evolve. The horseshoe itself will be reanalyzed as new data becomes available. This openness to revision is not weakness, it is resilience. The horseshoe stands at a crossroads between what is known and what is still forming. It confirms general relativity while deepening the mystery of dark matter. It clarifies cosmic structure while raising questions about early galaxy formation. It is complete enough to be convincing, yet incomplete enough to remain intriguing. There is also a quiet lesson in how the horseshoe reshapes our sense of scale. The ring looks large in images, but it represents distances so vast that the human mind struggles to grasp them. The galaxies involved are separated by billions of light years. The mass shaping the light spans hundreds of thousands of light years, and yet, all of that scale collapses into a curve that fits comfortably on a screen. This compression can be deceptive. It risks making the universe feel manageable, even familiar. But the horseshoe resists that illusion if contemplated carefully. Its simplicity is not accessibility, it is abstraction. The universe is not small because we can see it. It is immense despite being visible. Another reflective layer emerges when considering how lensing subtly changes our relationship with the past. The light forming the horseshoe left its source long before Earth existed in its current form. It travelled across an expanding universe, passing through evolving structures till it finally reached us. What we see is not a snapshot of reality, it is a memory. This memory is not stored intentionally, it is preserved by physics. Light carries information forward through time, but only as long as space-time allows it to travel. The horseshoe is therefore a preserved moment, not because it was saved, but because nothing erased it. This idea reframes how we think about cosmic history. It is layered into the present, arriving continuously as light. The universe is always revealing what it used to be. The horseshoe allows us to witness that revelation in a particularly striking way. It shows how the past can be distorted, magnified, and reshaped by the present. This interplay between past and present is central to cosmology. It reminds us that time is not a clean sequence of moments. It is a continuum where different epochs overlap in observation. The horseshoe embodies that overlap. Another quiet insight arises when considering how gravitational lensing challenges the idea of straight lines. Euclidean intuition tells us that the shortest distance between 2 points is a straight line. In curved spacetime, this is no longer true. Light follows geodesics, the straightest possible paths in curved geometry. The horseshoe makes those geodesics visible. This visibility is rare. Most geodesics are subtle, bending only slightly. The horseshoe amplifies the effect, making curvature undeniable. This amplification forces a re-evaluation of everyday assumptions. Space is not a neutral container, it participates. The horseshoe does not show us curved space directly, it shows us its consequences. There is also a philosophical resonance to this idea. If space itself is dynamic, then separation is not absolute. Everything exists within a shared geometry that responds collectively to mass and energy. The universe is not a collection of independent parts, it is an interconnected whole. The horseshoe is a quiet illustration of that interconnectedness. It also raises questions about how many similar phenomena exist unnoticed. For every horseshoe discovered, countless other lensing configurations likely exist beyond our surveys, hidden by distance, faintness, or misalignment. This suggests that the universe is filled with subtle demonstrations of its own laws that we simply have not noticed yet. Discovery, then, is not always about creating something new. It is about noticing what has always been there. The horseshoe waited billions of years to be seen, not because it was waiting, but because the conditions for observation were not yet met. This patience can feel humbling. It reminds us that human knowledge is young and the universe is ancient. And yet, despite that disparity, we are capable of understanding. This capability arises not from dominance or control, but from alignment. When theory, observation, and interpretation align, much like the galaxies in the horseshoe, insight emerges. This parallel is striking. The horseshoe exists because of alignment in space. Understanding exists because of alignment in thought. Both are fragile. Both are temporary. Both require precise conditions. As reflection deepens, the horseshoe begins to feel less like a singular phenomenon and more like a symbol. Not a symbol imposed by intention, but one that naturally invites interpretation. It symbolizes how the universe expresses complexity through constraint, how beauty arises without purpose, how truth is revealed indirectly. It also symbolizes restraint. The horseshoe does not overwhelm. It does not demand attention. It rewards those who linger. In a universe filled with extremes, it represents quiet precision. As this section comes to rest, the cosmic horseshoe remains what it has always been, a gentle arc of light shaped by invisible mass and curved space. But layered within that arc is a powerful reminder. Reality does not announce itself. It bends, it aligns, it waits. And when we are patient enough to notice, when we allow ourselves to slow down and look carefully, the universe reveals that its deepest truths are not shouted across space. They are written softly in curves of light. As the understanding of the cosmic horseshoe continues to deepen, attention slowly shifts toward an idea that feels almost uncomfortable in its simplicity. The universe does not need observers to be real. Yet observation profoundly shapes what reality looks like to us. The horseshoe exists whether or not anyone notices it. Its geometry is carved into space-time regardless of interpretation. And yet, the moment it is observed, measured, and reflected upon, it becomes something more than a physical configuration. It becomes knowledge. This distinction matters. The universe operates independently of awareness. Stars burn, galaxies drift. Space expands, all without regard for whether anything is watching. The cosmic horseshoe was bending light long before telescopes existed, long before Earth formed, long before minds evolved to wonder about it. Its existence was never contingent on discovery. And yet, discovery changes everything, not for the universe, but for us. When the horseshoe entered human awareness, it reshaped how gravity, space, and light were understood not as abstract ideas, but as visible, testable realities. What had once lived in equations became something that could be seen, traced, and studied. This transition from abstraction to visibility is rare in physics. Many foundational concepts, quantum fields, space-time curvature, dark matter, remain invisible, inferred only through indirect effects. The horseshoe stands out because it translates those invisible ideas into a visual form that feels almost intuitive. Yet even this intuition must be handled carefully. The ring appears solid and complete, but it is not a structure. It has no thickness, no substance. It is an image formed by multiple light paths arriving simultaneously. Each point on the ring represents light that travelled a different route through curved space-time. The horseshoe is not one path, it is many paths appearing as one. This multiplicity challenges the way we think about images. We are accustomed to images corresponding to single lines of sight. The horseshoe breaks that expectation. It compresses multiple realities into a single perception. This compression is a powerful reminder that what we see is often a simplification of what exists. Reality is layered, observation flattens it. Another subtle realization emerges when considering how gravitational lensing complicates the idea of uniqueness. The horseshoe looks singular, but its formation is not unique. Similar configurations can occur wherever mass, distance, and alignment permit. The universe does not reserve special treatment for specific locations. If observers existed elsewhere, they might witness their own versions of horseshoes, different galaxies, different distances, different alignments. Each would feel unique from that vantage point. This suggests that cosmic rarity is relative. The horseshoe is rare from Earth's perspective, but not rare in principle. Given enough viewpoints, enough time, and enough observers, similar phenomena would appear repeatedly. This perspective gently undermines the notion of cosmic privilege. Earth is not a favoured seat. It is simply one of many possible locations from which the universe can be seen. Yet this does not diminish the significance of what we observe. It reframes it. The horseshoe is meaningful not because it is unique in the universe, but because it is unique to us. Another layer of reflection arises when considering how the horseshoe reveals limits in our language. We describe it as a ring, a lens, a curve. These metaphors help, but they also constrain understanding. The horseshoe is not really a ring. It is not really an object. It is a mapping between distant regions of space-time. Language struggles with such mappings. We rely on familiar shapes to describe unfamiliar behavior. This reliance is necessary, but it can also obscure. The horseshoe invites careful attention to where metaphors help and where they mislead. For example, calling it a lens suggests glass, transparency, and intentional focusing. In reality, the galaxy is not focusing light deliberately. It is not shaped like a lens. It does not amplify light with purpose. The term is useful but imperfect. Recognizing this imperfection is part of scientific maturity. Models are tools, not truths. They approximate reality but never fully capture it. The horseshoe encourages this humility. Another quiet lesson emerges from how the horseshoe is studied over time. As telescopes improve, new details appear. Subtle brightness variations become visible, fainter structures emerge, models are refined. Understanding grows incrementally. There is no moment where the horseshoe is fully understood. There are only better approximations. This incremental progress mirrors how the universe itself evolves, not in leaps but in gradual shifts. Gravity shapes structure slowly, light travels patiently. Expansion unfolds steadily. The horseshoe is aligned with that pace. It rewards careful accumulation of insight rather than sudden revelation. This can feel frustrating in a culture accustomed to quick answers, but it is also deeply reassuring. It suggests that understanding is not fragile. It does not depend on perfect insight. It grows stronger through refinement. The horseshoe does not demand certainty. It tolerates uncertainty. There is also a quiet ethical dimension to this tolerance. It reminds us that acknowledging limits is not weakness, it is honesty. In cosmology, many questions remain open. What is dark matter? Why does the universe expand the way it does? What happened before the earliest observable light? The horseshoe does not answer these questions directly, but it constrains them. It narrows the range of plausible explanations. This narrowing is powerful. It allows theories to be tested, rejected, or refined. It transforms speculation into inquiry. The horseshoe participates in this transformation not by being dramatic, but by being precise. Another reflective angle arises when considering how the horseshoe blurs the line between explanation and experience. For scientists, it is a data set. For non-scientists, it can be an image that evokes wonder. Both responses are valid. The universe does not demand a single mode of engagement. It allows multiple layers of meaning to coexist. One can admire the horseshoe aesthetically while also appreciating its scientific significance. This coexistence enriches understanding rather than diluting it. The horseshoe does not lose meaning when explained, it gains depth. There is also something instructive about how the horseshoe challenges human-centered narratives. It does not relate to life, habitability, or destiny. It is not about survival or future exploration. It is simply about how reality behaves. This lack of narrative can feel unsettling. We are accustomed to stories with relevance to ourselves. The horseshoe offers none. It exists independently of human concerns. And yet this independence can be freeing. It allows us to step outside ourselves, even briefly, and encounter a universe that is not oriented around meaning or purpose as we define them. The horseshoe invites that encounter gently. It does not overwhelm. It does not threaten. It simply curves light and waits. As reflection deepens, the horseshoe begins to feel like a quiet teacher. Not because it imparts lessons intentionally, but because it embodies principles that become visible when observed carefully. It teaches patience by existing over long timescales. It teaches humility by revealing invisible influence. It teaches perspective by depending entirely on viewpoint. It teaches restraint by demonstrating power without force. These lessons are not imposed, they are, and inference is at the heart of understanding. As this section settles, the cosmic horseshoe remains suspended not just in space, but in thought. It is neither a spectacle nor a mystery to be solved. It is a demonstration, a calm, precise demonstration of how the universe operates when mass, space, and light align. It does not rush, it does not explain itself. It simply continues to curve light as it always has. And in doing so, it quietly reminds us that the universe does not need to be dramatic to be profound. Sometimes a single curve is enough. As the exploration of the cosmic horseshoe reaches deeper layers of reflection, one final and quietly transformative idea begins to surface. The universe does not reveal its deepest structure through objects, but through relationships. The horseshoe is not important because of what it is made of, nor because of where it is located, but because of how multiple elements, light, mass, distance, and geometry, interact across vast scales of space and time. Nothing in the horseshoe exists in isolation. The foreground galaxy cannot create the ring without the background galaxy. The background galaxy cannot appear as a ring without the foreground mass. The light cannot curve without spacetime geometry, and spacetime cannot curve without mass. Each element depends on the others. Remove one and the phenomenon dissolves. This interdependence is not unique to gravitational lensing. It reflects a deeper truth about the universe itself. Reality is not built from independent parts assembled together. It is built from interactions that only make sense when considered together. The horseshoe makes this truth visible. In everyday life, objects feel separate. A table is a table, a light is a light, a distance is a distance. But on cosmic scales, separation becomes less meaningful. What matters is influence. What matters is how one thing shapes the context in which another exists. The horseshoe is a map of influence. Light emitted billions of years ago is shaped by mass it encounters long after it was emitted. The resulting image depends on geometry that spans unimaginable distances. Cause and effect are not localized. They are distributed across space-time. This distributed causality challenges simple narratives. We often ask where something happens. The horseshoe resists that question. It does not happen at a point. It happens along a path. It happens through space. This forces a reconsideration of how events are defined. Not all phenomena are localized. Some are emergent, appearing only when conditions align across scale. The horseshoe exists because of alignment, not because of action. This idea becomes even more striking when we consider how stable the horseshoe appears despite the constant motion of everything involved. Galaxies are moving, space is expanding, light is travelling, and yet the image appears calm, fixed, and balanced. This apparent stillness is deceptive. The horseshoe is dynamic beneath the surface. It persists only because changes occur slowly relative to observation. Over millions of years, the alignment will shift, the ring will distort. Eventually, it will disappear. But within the human timescale, it feels timeless. This contrast between underlying motion and perceived stillness mirrors how much of reality operates. The Earth rotates and orbits constantly, yet we experience it as stable. Atoms vibrate endlessly, yet solid objects feel still. The horseshoe reflects this layered reality, motion hidden beneath calm. There is also a profound lesson here about how structure can emerge without design. The horseshoe looks intentional, it looks crafted, but it is not. It is the natural outcome of physical laws applied consistently over time. This challenges the intuition that order requires planning. In the universe, order often emerges spontaneously when constraints allow it. Gravity does not aim to create rings, but when mass, distance, and geometry align, rings appear. This is emergence in its purest form. The horseshoe is not an exception to chaos. It is chaos resolving into pattern. This realization has implications beyond cosmology. It speaks to how complexity arises in many systems, biological, ecological, even social. Given simple rules and enough time, structure emerges. The universe is a master of this process. Another subtle dimension arises when considering how the horseshoe reshapes our sense of cosmic scale. The ring appears large and dominant, yet it is composed of light from a galaxy that is itself a tiny fraction of the observable universe. This layering of scales, small within large, large within larger, creates a sense of nested reality. There is no final scale where understanding ends. Every level reveals another beneath it. The horseshoe sits comfortably within this nesting galaxy. It is large enough to reveal cosmic geometry, yet small enough to be studied in detail. It bridges scales that are otherwise difficult to connect. This bridging role makes it particularly valuable for cosmology. It allows theories developed at one scale to be tested at another. There is also something deeply human about how the horseshoe invites contemplation rather than urgency. It does not threaten Earth. It does not demand action. It does not inspire fear. It invites reflection. In a universe often framed through danger and extremes, this invitation feels rare. The horseshoe demonstrates that understanding does not always come from confronting the dramatic. Sometimes it comes from noticing the subtle. This subtlety aligns well with the pace at which the universe itself operates. Most cosmic change is slow. Most structure forms over immense timescales. The horseshoe is a product of that slowness. It rewards patience with clarity. Another insight emerges when considering how gravitational lensing blurs the line between foreground and background, not just visually, but conceptually. The two galaxies involved belong to different eras of cosmic history. One existed when the universe was younger, the other formed later, yet in observation they coexist. This coexistence collapses linear time. It allows different epochs to interact within a single image. The horseshoe is therefore not just a spatial phenomenon, but a temporal one. It compresses history. This compression reminds us that cosmic time is not experienced sequentially. We see the universe as a mosaic of different ages, layered together by the finite speed of light. The horseshoe is one tile in that mosaic. It also reinforces the idea that understanding the universe requires accepting non-intuitive frameworks. Time is not absolute. Space is not flat. Distance does not isolate. Objects do not appear as they are, but as they were. The horseshoe embodies all of these ideas simultaneously. There is a quiet elegance in how it does so without explanation or emphasis. It does not announce its complexity. It simply exists. This existence invites a particular kind of engagement, one that is slow, attentive, and open-ended. The horseshoe does not offer closure. It does not resolve into a final interpretation. It continues to be studied, reanalyzed, and reimagined as tools improve and theories evolve. In this sense, it reflects the nature of scientific understanding itself. Knowledge is not static. It curves, adapts, and deepens over time. The horseshoe mirrors that curvature. As reflection settles, it becomes clear that the cosmic horseshoe is not a destination in understanding. It is a waypoint, a moment where multiple lines of inquiry converge and briefly align. It connects gravity to geometry. It connects visibility to invisibility. It connects observation to interpretation. It connects patience to insight. And then, like all alignments, it continues quietly, unchanged by our attention. The universe does not pause to be understood. The horseshoe will keep bending light long after telescopes move on to other targets. It will persist as a configuration of mass and geometry indifferent to interpretation. Yet for a moment, a long human moment, it has allowed us to glimpse how deeply relational reality is. Not built from things, but from how things shape one another. And in that realization, the cosmic horseshoe offers its final quiet lesson. The universe does not reveal itself through force or spectacle. It reveals itself through alignment. As everything drawn from the cosmic horseshoe finally settles into place, what remains is not a conclusion in the usual sense, but a quiet recognition of how the universe prefers to reveal itself, not through declarations, not through boundaries, but through moments where relationships briefly align closely enough for structure to become visible. The horseshoe does not point forward to an ending, and it does not look backward toward an origin. It exists entirely in the present condition of space-time, an expression of how mass, distance, and geometry coexist right now, and yet embedded within it is a record of deep cosmic history stretching across billions of years without ever announcing that it carries such weight. This is perhaps the most important realization it offers. The universe does not separate past, present, and future cleanly. Light carries the past forward. Gravity preserves structure across time. Geometry connects distant epochs into a single image. What we see is never a moment. It is a layered arrival. The cosmic horseshoe is one such arrival. It brings together a galaxy that emitted its light when the universe was young, another galaxy that shaped that light much later, and an observer who exists long after both events occurred. None of these elements are aware of one another, and yet together they create something coherent. This coherence does not imply purpose, it implies consistency. The same laws that govern the early universe continue to operate now. Gravity bends space-time. Light follows curvature. Mass shapes geometry. Nothing special had to happen for the horseshoe to exist. Nothing extraordinary had to be added. The universe simply continued being what it is. This continuity is easy to overlook. We often imagine the universe as changing dramatically over time, and it does. But beneath those changes lies a deep stability. The rules do not reset, they do not evolve, they persist. The horseshoe is a reminder of that persistence. It shows that even as galaxies form, collide, and fade, the underlying framework remains intact. Space remains flexible, time remains layered, light remains obedient to geometry. And because of that obedience, reality becomes readable. Readable not in words, but in shapes. There is something profoundly humbling about this. The universe does not need to communicate. It does not encode messages. It does not design symbols. Yet its behavior produces patterns that can be interpreted, studied, and understood. Not because meaning was intended, but because structure emerges naturally from consistency. The horseshoe does not exist for understanding. Understanding exists because the horseshoe exists. This reverses the usual relationship between knowledge and reality. We often think the universe becomes meaningful when we understand it. In truth, understanding becomes possible because reality behaves reliably. The horseshoe behaves reliably. It bends light exactly as mass and geometry demand. It does not exaggerate. It does not conceal. It does not compromise. And that reliability is what allows trust. Trust that equations describe real behavior. Trust that unseen mass truly exists. Trust that space is not merely empty distance, but an active participant. The horseshoe strengthens that trust not by explanation, but by demonstration. It also leaves us with a gentle caution, because the horseshoe looks calm, balanced, and precise. It can create the illusion that the universe is orderly everywhere in the same way, but this is not true. The horseshoe is an alignment, a moment where complexity resolves into clarity. Many regions of the universe are far messier. Understanding grows not by assuming uniformity, but by recognizing where clarity emerges and where it does not. The horseshoe teaches discernment. It shows that not all beauty is universal, and not all truth is symmetrical. Some truths appear only under specific conditions, and those conditions are fragile. The alignment that creates the horseshoe will not last forever. Over time, motion will dissolve the ring, space will stretch. Geometry will shift, the image will fade. This impermanence does not diminish its value, it defines it. The horseshoe exists in a narrow window where structure becomes visible. Outside that window, the same physics continues, quietly, invisibly. In this way, the horseshoe reflects the nature of understanding itself. Insight appears when conditions align: attention, patience, perspective. When they drift apart, understanding blurs. The universe does not guarantee clarity. It allows it, and when clarity appears, it does so without urgency. The cosmic horseshoe does not rush us. It does not demand awe. It does not threaten insignificance. It simply curves light and waits. It invites a slower way of engaging with reality, one that values alignment over explanation, relationship over isolation, and patience over certainty. In a universe often described through extremes, the horseshoe stands as something rarer, a quiet demonstration of coherence. Not dramatic, not violent, not loud, just precise. And in that precision, it leaves behind a final impression, not of mystery to be solved, but of reality behaving exactly as it must, whether we are watching or not. The universe does not need to be understood to exist, but when we are still enough to notice how it bends, curves, and aligns, it allows us, briefly, to understand how deeply connected everything truly is.